guys, today we will be solving find all numbers disappeared in array Leetcode problem. So let's go to the problem statement. We are given an array called nums, and which contains n integers. Where nums, where each of the elements is in the range from 1 to n. That's basically our input, and for the output, we are still returning an array of all integers in the range 1 to n that do not appear in the nums. So basically, we are looking for the numbers that are not in the input array. So our output will be all the numbers that are not appearing in the input array. If we go through the examples, we see that we here have 8 numbers, 8 elements. And as you can see, this is the range from 1 to 8. So n is equal to 8 here. And the numbers that are missing are, so we have 1, 2, 3, 4, and then 5 is missing, and 6 is also missing, and then 7 and 8 are there. For the second example, we have only 2 numbers, so the maximum number we can have is 2. And in this case, and so the range is from 1 to 2, and the only number that's missing is 2 because we have 2 ones. Now, a straightforward approach to this problem, you can call it a brute force solution, would be to declare a hash map set or array of Boolean of an array which has a length of n, and then mark each number that exists in the input array by marking the corresponding index. So for example, let's say we choose the option with the Boolean array. For the second example, because it's a shorter one, we will have an array of length 2, which with default values of false. And then we would iterate over the numbers and then map the numbers to the index. So in this case, we have 1, and the corresponding index will be 0. This is our first element, and then we will turn this to true. And then the second number is also 1, so nothing would change. We would iterate then over this helper data structure and just check if the number exists in the array. And then how do we do that? We basically just check if the index is set to true. So if the index, let's say here we have index 0 is set to true, that means that index plus 1, in this case it's 1, the value 1 exists. We already saw it in the input array. For the second element, index 1, which basically is set to false, so that means that index plus 1, 1 plus 1, number 2 doesn't exist in the array. But that might not be the best solution. The best solution will be, and as you can see in the follow-up, is to have it without an extra space and run it in a linear time complexity, which corresponds to the constraint that the maximum numbers we can have in arrays 10 to the 5th. So our desired time complexity will be linear time complexity, but the special requirement is to have constant space complexity, which can be tricky. So how do we do that? Like, our first hint should be that we have to reuse the properties of the array to somehow mark the numbers that exist, and then on our second iteration have a marker that says basically, okay, this number exists, but and all in the opposite, like the number doesn't exist. And how can we do that? Like, we can first check with the interviewer what are the properties of the array. And as you can see here, the properties is that the numbers that appear in the array are only from 1 to n. So all numbers that we have will be from 1 to n. We can use that property to somehow mark the numbers that are appearing in the array. And how are we going to do that? We know that the maximum number we can have in array is n. So we could basically just add to the corresponding index the n. And in that case, we will know that, like, okay, we added n, and we know that the number that corresponding index exists. We will go through a real example. This is the same example that is given by the problem statement. And we will see how the markers behave. How can we set the markers using the length of the array, which is the maximum value that we can get in the as an element in the input array, and how can we use that marker to find the disappearing elements. So we will go through an array just by declaring the I variable that will just loop over the input array. So we have to go from 0 to the length of the array, which in this case is 7. So we will start with 4. 4 is lesser than 8, so we just have to find the index that 4 matches to. And how do we find the index? Well, it's the 4th element. So the index will be just the value minus 1. So in this case, it will be number index 3. So when we find the index, corresponding index, so here, we will increase the value at that index by the length of the array, so that we know that we have encountered element that corresponds to this index. So in this case, we will have 7 plus 8, which is equal to 15. And we will move to the next element. Next element is 3, and as always, like to find the corresponding index, we'll just decrease the value of the element by 1. So 3 minus 1 is equal to 2. So we just increase this value again by the length of the array. So 2 plus 8 is equal to 10. Now we are at our third element, but this element, as you can see, is not the same as we have as our default, in our initial input. As you can see, it's like 2, it's 2 in the initial input, but like because of the transformations and markers that we put, it's now 10. To subtract the effects of adding the length of array one or multiple times, we will use the modulo operator. So if I have 10, I will first decrease it because I have to offset it by 1 to find the corresponding index, which in this case means 10 minus 1 is equal to 9. And then we will do the modulo operator to subtract the effect of adding length of the array, which in our case is 8, once or multiple times. So in this case, we know that the result of this operation is 1, which is also the same index if we only look at our initial input. So 2 minus 1 would be 1. So we go to the element at our first index, and we increase it by the length of the array. So in this case, it will be 11. 3 plus 8 is equal to 11. The same logic goes for 15. So first we decrease it by 1. For 15 minus 1 is 14, and then modulo of 14 modulo 8 is equal to 6. So our element will be the index that we are looking for is 6. So we will increase this number by 8 again, and 3 plus 8 is equal to 11. Now 8 is okay, it's lesser. So this is our max element that we can get. So the corresponding index is the last index. So we just increase this value by 8. 1 plus 8 is equal to 9. 2, again, corresponds to the index. So 2 minus 1, it corresponds to the first index. And this is just hard to update. Yeah. And 11 plus 8 is equal to 19. And we get to the number at the index 6, which is 11. We first, because it's greater than 8, we first decrease it by 1, it's 10. And then 10 modulo of 8 is equal to 2. So we are looking at the index 2. And if you note, our element in the initial input is 3. So 3 minus 1 will be equal to 2. So we just have to increase this number by 8. So in this case, it will be 10 plus 8 is equal to 18. And the last number, we just do the same operation again. 9 minus 1 is 8. 8 modulo of 8, it fits perfectly, so it will be 0. It will correspond to the first index. And as you can see in the initial input, we have 1, and 1 minus 1 is 0. So we just increase this number by the length of the array, which is basically 4 plus 8 equals to 12. Now, to find the numbers that are missing, the only thing that we have to do is to traverse the array, modify the array again, and check if the number is equal or lesser than the length of the array. Why can we do that? Because if we we know that the smallest number we can get in the input array is 1. So if we find 1 in the array, that means that we will find its corresponding index and then add the value, whatever. So it will be 1 plus 8 equal to 9, which is greater than the length of the array. So we know we encountered number 1. In this case, for example, we know that we encountered number 1 because this value here is larger than 8. And in the input array, we do have number 1. The things that we are looking for are actually the values that are lesser or equal to the length of the array, to the n, which in our case are these values. So we know that we haven't touched these values, we haven't marked them, which basically means the value that correspond to these indices haven't been found in the array. And if you think about it, we just do the reverse operation now. As you remember, we would be decreasing the value to find corresponding index. In this case, we will just increase the index to find the corresponding value. So 4 plus 1 will be equal to 5. 5 is missing from the input array, as you can see. And 5 plus 1, this index, is equal to 6. And 6 is also missing from the input array, which are basically our numbers that disappear from the input array. So we just return 5 and 6 by just traversing the array one more time. Well, let's code up the solution. First, we will declare the resulting array that will return from our function as our final solution. To do that, we will just declare a list of integers in Java programming language. Just for the readability purposes, we will declare a helper variable that corresponds to the length of the array. Next, we will traverse through the array, and for each element, we will find the corresponding index by first decreasing the value of the element by 1. So because arrays are 0 index and we have to offset by 1, and then subtract any effect of adding length of the array that we had before by using the modulo operator. And when we find the right position, we will just add the length of the array to mark that the number that corresponds to this index has been found in the array. Next, on the modified array, we will traverse through the modified array, and for each element, we will check if the value is lesser or equal to the length of the array. And if it is, then we can use that index to find a real value that has disappeared, that's not appearing inside the input array. How do we do that? We just do the reverse operation. Instead of decreasing the value to find the index, we will increase the index to find the value by 1. And in this case, we will just add, so in this case, index plus 1, we will just add it to the resulting array. Finally, we will just return the result as our list of integers as our result of the function. And the time complexity for this solution is we just basically have two for loops, so it's linear time complexity, but we haven't declared any helper data structures. We just have the resulting data stores that we use to return as a result from our function, which doesn't contribute to the total space complexity. So we can say the space complexity is constant because we are only operating in place, you can call it, on the input array.